Avogadro's law. Ne? This is a chemistry grade 10 subtopic under quantitative aspect of chemical change. Ne? So now, first thing first, you need to know about this law. It is its definition. How do you define Avogadro's law? Ne? Now, how do you define it? So Avogadro's law, it says that 1 mole of any gas occupies the same volume and the same temperature and pressure. So if you can break this law into small pieces, it says that if we have two gases, we have got two gases here. Now, these two gases, they've got moles. Let me just say this gas, I could say, for example, we can have hydrogen gas and nitrogen gas. Hydrogen and nitrogen gas. Yeah, both guys. So now, each gas has got 1 mole or 2 cylinders. You've got 2 cylinders. You fill the first cylinder with the first gas, which is hydrogen, and the second gas with nitrogen. So, renale, the gas is a pedi, renale, its own mole, and this one its own mole. They're the same, 1 mole. So, how do you get a cylinder, a bottle cylinder? They will have the same volume and same temperature, and even the pressure. That's basically the definition of Avogadro's law. Now, this definition has got various concepts in it. We talked about a mole previously. Now we're talking about a volume. And we've got temperature and the pressure. Now we need to define this concept because this formula has got this law has got a formula basically. Now this formula we can use it or we can define it through a triangle. We've got our on top we've got V and V M, and I will explain them right now. So now we've got 1 mole. 1 mole, and here N stands for a mole. 1 mole. And we've got our volume here. This V on top, it is our volume. And temperature, pressure. This temperature and pressure goes intertwined to form Vm. Now, V for volume. And its SI unit, or it is measured in dm cubed. Yeah, but then we've got number of moles, or N. N for number of moles. It is measured in M. It is measured in mole. Okay. Then we've got V, capital letter V and small letter m. This one, it represents our molar volume measured in mole per decimeter cubed. Mole per mole multiplied by, with a dot here, dm to power -3. Label. Now, this molar volume, it is measured at standard temperature and pressure. Real temperature and pressure. Usually going forward, you will hear more about STP, especially in few questions you're gonna deal about STP. Even in examination, you want to deal about this STP. What is the meaning of STP in full? This is an abbreviation of standard for S, temperature for T, pressure for P. Standard, temperature, and pressure. And this STP stands for our molar volume, or the value of our molar volume. Molar volume, this VM has got its value, or a constant. What is the constant? It's a number that is used everywhere as long as the question will involve standard temperature and pressure, or molar volume. And the value for molar volume all the time is equal to 22,4 dm cubed. This is the standard formula. This is the constant. That means you use it all the time. Means already molar volume has got its value, which is equal to 22,4. It has got its value. So you will hear more about constant standard temperature and pressure. And when the same as use this formula, please, they will only ask you to find the volume or the number of moles, but they will never ask you to find the molar volume, because of what? Molar volume has got a constant, or this value 22,4 that you're gonna use all the time. How about molar volume? In any question that involves Avogadro's law, you only be asked to find the volume and the number of moles. That's the logic behind this concept. Thank you, guys. Now, how are we gonna use this formula? So this formula is very simple. So usually, you can, this is the standard formula. N for number of moles is equals to V over Vm. V for volume over molar volume. So you can use this formula to find either volume or number of moles. And you can use anyhow you like it, guys, as long as everything is proper there. Yes. Some people will say that I prefer saying, if I want to find the volume, I can say volume is equals to number of moles multiplied by molar volume. So there are many ways to find number of moles and volume. Another way is that one of saying or volume is equals to number of moles multiplied by molar volume. So that V, if it's on top, when you want to find volume, you must multiply number of moles and molar volume. When you want to find number of moles, you need to divide volume by our constant, which is molar volume. Guys, let us do some few questions. If 4 moles of hydrogen peroxide, this is the formula for hydrogen peroxide, decomposes, if you've got 4 moles of hydrogen peroxide, if this 4 moles gets to be used, calculate the volume of gas formed at STP. Now, that STP is haunting us right now. So it's very simple. When we talk about STP, we standard temperature and pressure, and its constant 22,4 dm. This is our molar volume, basically. So now, how about STP? Think of Avogadro's law. In the future, how about at STP? Think of this formula. Think of this concept. Now, what are we given here? We are given number of moles, which is 4. We are given number of moles, which is 4. What are we given again? Come on, wait, STP. Or they say you must find the volume. Already, if they say you must find the volume, you think of this law of Avogadro. Then, what is the value for our molar volume? Is our constant, which is 22,4. They will not tell you that the value for molar volume is equal to 22,4 in the examination. They will not tell you, man. You need to know it by heart. To grade 12, by the way. To even university level, you need to know this constant by heart. Now, they say you must find the volume here. How are you going to find the volume? Please pause the video and go through the example. Please pause the video and go through this example, my sister. Now, you can use any formula between the two. Any formula between these two. These two formulas derives from this one, by the way, from our triangle here. So you can use this one or this one to find the volume. It's not a problem. So let us use the simplest one, which is V is equals to N multiplied by Vm. Number of moles multiplied by molar volume. Okay? What's the value for number of moles? Keep going. Is equals to 4. Okay? 4 multiplied by Vm, keep going, our constant, which is 22,4. Therefore, visit your calculator here. 89,6 dm cubed. This is the answer for volume. Dm cubed all the time. Ne? So now going to grade 12 with your chemistry, you need to convert. Your volume must be all the time be in this form, dm cubed. It's assigned is in dm cubed, ne? Unless otherwise. So guys, number 2, it says that in another experiment, 80 grams of hydrogen gas reacts with nitrogen gas to form ammonia. We talk about we have got gases here. Yeah? So they're saying that 80 grams. So now we have got gases here. We've got hydrogen gas. It reacts. Come on, so if they say it reacts, there's a reaction taking place here. How about hydrogen gas? Think of H2. H2 is a hydrogen gas again. And nitrogen gas, keep going, it reacts again. We say plus nitrogen gas. Who to it forms what? Ammonia. NH3. Right? Very simple and key. Ne? Now, first question is that calculate the number of moles of hydrogen gas. Number of moles of hydrogen gas reacted. Hydrogen gas reacted. Very simple and clear. You must focus only on hydrogen gas. This one, H2 only. Now, hurry. About the number of moles. Now, you cannot use Avogadro's law because of what? We don't have the volume here. But the only formula you can use to find number of moles here, in most cases for now, since now we've got the mass. We've got the mass. Number of moles are hydrogen gas. And basically, 80 grams of hydrogen. That means this 80 grams is only for hydrogen gas. 80 grams is 8. I mean, our 80 grams is mass number of hydrogen gas that it consists. Mass number of hydrogen. 80 grams. Remember the formula number of moles is equals to mass number over molar mass. Molar mass. Molar mass wa in molar mass wa hydrogen. Now, what is the molar mass of hydrogen? Remember hydrogen. For you to find the molar mass of any atom or any element, but in this case, you only find the molar mass of hydrogen gas using these symbols, H2. Remember H2. We have invisible one here. So for you to find the molar mass of hydrogen gas, you will say, what is the atomic mass of hydrogen gas on the periodic table? What is the atomic mass? 1 of hydrogen on the periodic table is 1. Therefore, you're going to say that 1 multiplied by your atoms here, or your ratios, basically. How many atoms of hydrogen do we have here? We've got 2 hydrogen atoms. Then this 2 will multiply with this 1 that is in front of hydrogen gas. So 1 times 2 is 2. So it's about 1 atomic mass multiplied by 1 times 2 the atoms, which is 2, is equals to 2 grams per mole to power -1. This is power -1. I hope you guys get it. Now, number of moles. Number of moles is equals to mass number over molar mass. What is the value of mass number? Is 8. What's the value of molar mass? Is 2. Therefore, our answer is 40. 80 divided by 2 is 40 mole. I hope you guys get it now. I hope you guys get it now. Now guys, number B, they say that you must calculate volume of nitrogen gas used at STP. How can you compare the STP? You think of Avogadro's law. You think of molar volume. You think of 22,4. Ne? How about the volume of nitrogen gas here? So without going any further, just use this formula, guys. Because about the volume here, and you've got the volume and STP here, and volume is here, and our STP is here. Okay? Very simple and here. Let's just substitute. Again, volume is equals to, but before let us collect data here. So first thing first, we need to collect data. Now data volume, we need to find the volume. Second, data key VM, molar volume. Our STP is equals to 22,4. The last thing key, number of moles. Number of moles. Do you have number of moles? No. That's where the problem starts. I don't have number of, and we have 2 unknowns, and that's very, 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 very not impossible. So now the question says that you must find the volume, but us in our own space, we need to find the number of moles for hydrogen gas. So guys, we'll come back to that one. We'll come back to it. Let us write our formula again. It's very important to come back here. NH2 plus N2, it forms NH3. Now, in this case, we've got H2 plus N2, it forms NH3. Why do we come back here? Because we don't have number of moles of what? Of nitrogen. And from our question here, there's nothing in terms of information for nitrogen gas here. We don't have anything. But we only had the mass number for hydrogen gas only, but not for nitrogen gas. So for us to find number of moles for nitrogen gas, we need to know, remember, number of moles for hydrogen gas, we need to know the molar mass. We already have the molar mass of nitrogen, but we don't have the mass of nitrogen gas. So the simplest way to find the number of moles for nitrogen gas, we need to make sure that we create a ratio. Ratio how? A ratio in terms of since well now hydrogen is reacting with nitrogen here, so we need to use the ratio for hydrogen and nitrogen to find the number of moles for hydrogen gas. Since well now we already have got the number of moles for hydrogen gas, so you're going to use the ratio of hydrogen gas to find the number of moles for nitrogen gas. Because of what? We already have got the number of moles for hydrogen gas. So now, is this formula balanced? The first question you need to ask yourself is this formula balanced? The answer is no. How do you balance the formula? Very simple. On our left, we've got hydrogen and nitrogen. On our right, we've got hydrogen and nitrogen. How many hydrogens do we have? We have got 2. We've got 2 nitrogens. Hydrogen on our right, hydrogen on the 3, nitrogen on the 1. So, which side needs to be filled between the left and the right? And let's start with hydrogen. We've got 2 hydrogen ratios or atoms, and we've got 3. Which one needs to be filled? Which side needs to be filled between the left and the right? Is the left side, because I've got 2 hydrogen gases. Now, for you to balance the 2 sides, we need to start with only putting 2 next to hydrogen gas. And when you put in 2 here, we are testing. So this 2 will say 2 times 2. Keep 4. We write 4 here. Now, when you check again, hydrogen already on our left is 4 and on our right is 3. And which side needs to be filled more? Since now we've got 4 on our left, already you need to fill the right side of hydrogen. Which value can we put on our left? We can write in 2 again. And since now we've got 3 hydrogen gas, we can write 2 here. And on our right, we can write 2 next to nitrogen. This 2 will affect nitrogen and hydrogen. And since now we've got 1 invisible 1 here, for nitrogen, 2 times 1, keep 2. And then 2 times 3 for hydrogen, keep 6. Why? We've got 6 hydrogen gases and 2 nitrogen. So now nitrogen is balanced. You want to leave it. Go back to the one that is not balanced, which is hydrogen. Now on our left needs to be filled because we've got 4 and 6 here. We need to fill the side with the lowest ratio of atoms, which is our left side. Therefore, you're gonna say, okay, for us to reach 6 from 4, it's an even number. For us to reach 6 on our left for hydrogen, you need to say, okay, we've got 2 here already. Here, we remove this. Since we have this 2, it has failed. We remove it. Now we check which value which number can I multiply with this 2 to give me 6. I know it's 3 because 3 times 2 is 6. Therefore, is 6. Therefore, our equation is balanced. I hope you guys get it. I hope you guys get the concept of balancing equation here. Yes. Now, we're not done. Our aim is to find the number of moles for nitrogen gas. And you're going to use the ratio, basically. Now, how do you use the ratio? Remember, we have got 3 ratios of hydrogen gas. And which means you look at this value that is in front of hydrogen gas. We have got 3 atoms of, we have got 3 ratios of hydrogen gas, and you've got 1 for nitrogen gas. And why? So now it's about 3 is to 1. And here is a ratio. It's 3 is to 1. Yeah, 3 is to 1. Now, since now our aim is to find the number of moles for nitrogen gas. And here for hydrogen and nitrogen. Hydrogen. And now, what are the number of moles of hydrogen? 40. And we found 40. What is the number of moles? What is the number of moles for nitrogen gas? Unknown. You don't know. Therefore, you put in X here. It's unknown. And you need to find the number of moles for nitrogen gas. We put in X here. And so our aim is to solve for X. How do you solve for X? First, you do what? You cross multiply. When you cross multiply here, it's about 3 times X, you get 3X. You put in equal to 1 times 40, keep 40. Therefore, X and I divide both sides by 3. Therefore, X is equals to 40 divided by 3. So now, number of moles for nitrogen gas equal to 40 divided by 3 and mole. This is the number of moles for nitrogen gas. I hope you guys get it. Now, after you found number of moles for nitrogen gas, you then come back to your equation. So finally, 2 known values. Volume. Remember, you can use this one. Volume is equals to number of moles multiplied by molar volume. What are the number of moles for nitrogen gas? I think for nitrogen gas, 40 over 3. 40 divided by 3 multiplied by 22,4. I hope you guys get it. Now, calculator. Or 40 divided by 3 multiplied by 22,4. Your answer is 298,67 dm cubed. This is the answer you need for volume. Therefore, you are done. So guys, we're going to deal with more questions of this nature in the next session. Thank you very much.